In this problem, we are given a circuit diagram, and we need to calculate V0 if our V source is this voltage and a couple other voltages down here. Basically, we're going to be doing the same thing a couple different times, and then we need to solve for G, which is specify the range Vs required to avoid amplifier saturation. We're going to do this after we get the formula and solve for A through F. To get the formula to solve for A through F, we know that we are going to have to involve V0. We know that we're going to have to also involve Vs. So the easiest way to do this is a node voltage method. If we look at this node, it's the only node in between them. So we're going to call this Vn because we know there's a negative terminal here. We have Vp, which is our positive terminal, and we know that Vn is always equal to our Vp. And in this circuit diagram, our Vp is grounded, which is denoted by this arrow. So it's equal to 0. Now we can start writing our equation. Our Vn is our center, so we're going to put it out front. Vn minus our source voltage, which is Vs, and this is all going to be over the 16 kilo ohm resistor because Vs is right here and it's going into our Vn over the 16 kilo ohms. And we're going to do the same for our V0. We know we have some negative feedback coming back this way and into this node. So we will have a plus Vn minus the V0. This is all happening over the 80 kilo ohm resistor set equal to 0. Now we know from right here that our Vn is equal to 0. So we can get rid of this and write this as 0. And then I'm going to rewrite our equation, but first I'm going to simplify by multiplying everything by 80 kilo ohms. That way we can get rid of the denominator. If we do that, we are going to get a negative 5 Vs. And if we move our V0 over, we're going to get an equals to V0. So this is our formula. V0 is equal to Vs times a negative 5. I'm going to rewrite that down here. And now we're just going to plug in our values. These are going to go into right here, all of them, because this is the formula for it. We found our formula and now we just need to plug things in. And these will be the values that we get from this formula. Next, we need to specify the range Vs required to avoid amplifier saturation. We are going to use the same formula right here. We're just going to bring it down, and instead of plugging in Vs, we will be plugging in our V0. We know that this node and this node are the maximum voltages and the minimum voltage that this could be. Because our op amp is linear, so it'll be at negative 15 like this, and it'll go up linearly until it reaches 10 volts, and then it'll stop and it'll go like this. So the negative 15 volts acts as our lower bound and the 10 volts acts as our upper bound. We're going to plug both of these into our V0. First we're going to do our negative 15 volts and we're going to do our 10 volts. Plugging this in for our V0, we are going to get negative 15 is equal to Vs times a negative 5. That means our Vs will be equal to 3. So this is one answer. And then we are going to get 10 is equal to Vs times negative 5, which is obviously that negative 2 is equal to Vs. And this is our second answer. Now, this means that the range is going to go from the lowest possibility, which is our negative 2, to our highest possibility, which is 3. And that is the answer and how to do this problem. If you have any questions about the material covered, you can leave them in the comments below. If you want more introduction to circuit analysis, as well as notes for this material, they'll be in the description.